Okay, so this is just review stuff, but let's go ahead and go through it just in case. These laws are all laws you should know. Anything to the 0 power is 1. 3 to the 0 is 1. A million to the 0 is 1. -5 to the 0 is 1. Got it? Anything to the first power is itself. That works for 1, 9, -2, and a billion. If you are multiplying and the bases are the same, you're going to add the exponents. So x cubed plus x, or times x to the 5th would be x to the 8th. You just add the exponents. If you're dividing, you subtract. Bless you, by the way. If you have a power to a power, that's when you get to multiply. So x to the 5th cubed would be x to the 15th. If you've got two bases you're multiplying together, and together they're raised to a power, it's kind of like distributing. So the a affects both of them. Let me zoom in a little bit more. If you're dividing, same kind of deal. A affects both of them. If you have a number raised to a negative power, that's where it sticks it on the bottom. So, for example, if you have 9 to the -2, that's the same thing as 1 over 9 to the +2, which is 1 over 81. And sometimes that gets flipped. Sometimes it looks like this, 1 over 3 to the -3. And that's the same thing as we're going to bump him to the top. When we bring it to the top, the exponent's now positive. So 27. Questions? Okay, let's look at the square root one. If you have a fraction of an exponent, remember, inside over outside. This inside number goes inside the radical. The denominator goes on the outside. So if you have x to the 1/3, inside over outside, there's your 1/3. And that works every time. Let's go ahead and look at some examples. It says -3 to the -2. Now be really careful. This actually means the opposite of 3 to the -2. If there were parentheses around the -3, the whole thing would be to the -2, but I don't see parentheses. So even when you type this in your calculator, if you don't put your parentheses in the right place, your calculator's going to spit out the wrong answer because you didn't know what to type in. So be really careful. So this is the opposite of 3 to the -2. 3 to the -2, isn't that 1 over 3 to the +2? Yes? And so the answer would be -1/9. Does everybody see how I got that? So be careful. This right here does not equal that. Does everybody see the difference? Those are two different things. Okay, let's look at the next one. What do you think we ought to do? Can we distribute? Are you multiplying these bases? You're adding them. The -1 does affect both of them, but kind of maybe not in the way that you think. I say let's figure out the inside first. Forget this dude on the outside. Let's just look at the inside. 2 to the -1. What is that? 1/2. So it's 1 over 2 to the +1. Plus, what's 2 to the -3? Right, or 1 over 2 to the +3 first, for those of you that need the extra step. That's fine. So I have 1/2 plus 1/8 on the inside, and then it's to the -1. We should probably add these together first. You can't just distribute that -1. It doesn't work like that. So 1/2 plus an 1/8. Let's change both of them so that the bottoms are 8s. So that'd be 4/8, right? So what we really have here is 5/8 to the -1. If it's 5/8 to the -1, remember, this little -1 affects both of them. Or if you wanted to, you could just put the whole thing under a 1. Either way, you're going to get the same answer. So you flip it, very good, and we get 8/5. Questions? I cannot guarantee that on this part of your test you'll be able to use your calculator, so make sure you can do that by hand. Okay. Well, I know your calculator is smart. I know your calculator can do that. You can do this. Alrighty, so the next one. And there's a couple of ways to approach some of these guys. You don't have to use the same steps I do, but we should have the same answer. So I've got 2 to the 1/2 and I have 12 to the 1/2. Why can't I just go ahead and add those exponents? The bases don't match. You have to have matching bases. Inside over outside? Yeah. Okay, so if we do that, then I get radical 2 times, and this is going to be radical 12. Okay, so let's see here. Isn't that radical 24? Okay, so then what? We got to simplify this guy. 2 radical 6 is what Tanner is saying, and I'm going to agree. Because this is 4 times 6. Square root of 4 is 2. 6 is on the inside. Are we finished?
No.
How come? You've got to put it in the same form it came in. If they give you exponents, you got to give back exponents unless they say otherwise. So it's inside over outside. So that makes that 2 times 6 to the 1/2. Questions? Okay, so everybody knows where I got 2 radical 6, yes? Okay, 6 is to the first power, right? Regular old square root, that's a 2 on the outside, really, right? They just don't put it. It's understood that that's 2. Yes? So inside over outside, 1 over 2. That's where the half came from. Does that make sense?
How can you split up? I don't understand.
Why would you not leave it in the radical?
No, that's what I'm saying. If they give you exponents, you have to give back exponents, unless they say otherwise, Brian.
Well, I mean, I know it's like a problem.
Because does 2 radical 6 equal 12?
No,
It's a 2 times 6 to the 1/2 is the same thing as 2.
These two equal each other.
And you can't times 2.
Yeah, their exponents don't match. And the bases don't match. All right, next one. 27 to the 2/3. Inside over outside, she's got it. So we have inside over the outside. So it's the cube root of 27 squared. What's the cube root of 27? 3. And there's 2 27s in there, so we can do it again. So that's 9. There's lots of ways to approach that. You don't have to do that my way. Next page.
Wait, so
Yep. That'd be 3 times 23. Yes, ma'am. And actually, the reason that works is because this right here is the same as the cube root of 27 times 27. So the answer to that one's 3. The answer to that one's 3. So 3 times 3 is 9. Yep, good question. Back page. They want you to simplify. We're not going to do all of them. Now remember, we're multiplying now, so this 1/2 affects both of these guys. 25 to the 1/2, what does that mean? The square root. What's the square root of 25? 5. And we've got 8, a power of 8 raised to the 1/2. That was where you multiply. What's 8 times 1/2? So it's x to the 4th, and that's your answer. Next one, there's several ways to approach this one. Just look at the numbers, first of all. What's 6 over 3? 2. So that part's done. That's going to be a 2. This part, we've got bases that are being divided. Same bases that are being divided. What do you do to the exponents? Subtract. I've got 3 over 2 and a 1. Why don't I make this 2 over 2? Isn't 2 over 2 1? 3 halves minus 2 halves is 1/2. So the answer is 2n to the 1/2. Questions? You guys did that one. You don't like it. Check your answer with your neighbor when you finish. Some of you guys either finished really quickly or you didn't even start it. Next, do you guys have an answer?
Do not know how to do it.
Okay, there's lots of approaches, so you might approach this differently from me, and that's fine. In the end, we should have the same answer. I just went ahead and said, I know that this negative 1/4 affects everybody in here, so I just went ahead and sort of distributed. So if I just focus on the x part, a power raised to a power, what do you do to the exponents? Multiply. What's a negative times a negative? And what's 16 times a 4th? So on the top, I have x to the 4th. Now let's look at the 81. It's on the bottom, and that's okay. 81 to the first power. So 81 to the negative 1/4. I'm just going to write that for now. I'll deal with it later. It does affect it. I'll just write it for now. Then I have the y part. What's 4 times negative 1/4? Negative 1. And what is positive 8 times negative 1/4? Negative 2. X to the 4th, there's nothing wrong with him. We're just going to leave him there. Let's look at the 81. 81 to the negative 1/4. That exponent is negative. So what happens to the 81 to the 1/4? Bumps to the top. To the 1/4. What does that mean? 4th root, which the answer is 3, right? The 4th root of 81 is 3. So I'm going to have a 3 on the top. Let's look at the y. Y to the negative 1. What happens? He bumps to the top, and the exponent's a positive 1, so I don't need to write it. How about z to the negative 2? He moves to the top, and that 2 becomes positive, and that's it. Next, are you guys good? Because I know y'all just sat there. At least Smith did over there. And that's okay. Now that you've seen it, you kind of remember. Is everybody okay?
Yeah.
Do we need to do another one?
No. What do you say?
Yes. I don't know. Here, try another one. There you go. Try that one. It is a Z. Sorry, I'll put a little Z thing through it. There you go. There are lots of ways to approach it. You do what you're comfortable with. This one might be a little messier. Because you asked for another example. I reduced 9/6. You don't have to do that first. You just can if you want. In the end, you get the same answer. It doesn't really matter. Yeah, that one's pretty. It's gross.
It's radical in the denominator.
Yeah, there is a radical in denominator, which you can't have. Cute. Presents.
Ooh.
Like presents. Kind of big. I don't know what that is. Brian's right, you guys. This is technically a radical, which you can't have in the denominator. So we'd have to go through and fix it. I apologize. This is a problem I made up, so I'm not going to keep going. I'm not.
Wow.
It's not going to be that, I mean, it's not going to be that crazy for you on your assignment. It's just not. But I do want to move on. Let's grab these other two so we can get going on our quiz. It says write using rational exponents. You're just changing it from square roots to exponents. Remember, it's inside over outside. This is a regular old square root. So there's kind of like a hidden 2 there that you can't see. So inside over outside, 2 over 2 is 1. So it's x to the first power. Y, 6 over 2 is 3. And z, 1 over 2 is a half. You're done. That's all you have to do. Next one. 27, you know what the cube root of 27 is. It's 3. Inside over outside, so I have x. Heard it, squared, there we go. And y is going to be to the 1/3. Inside over outside. That's it. That's all we're doing today. Simple review.